Imagine a Linux system where updates never break your setup and every configuration is perfectly reproducible. Sounds like a dream? Meet nixos, a distribution built around a functional package manager that treats software and system state as immutable artifacts. Could this be the blueprint for the next generation of desktop Linux? Let's unpack it. Setup: why the problem exists. For decades, users have battled dependency hell, half-broken upgrades, and the slow creep of tiny, untraceable tweaks that make two identical machines behave differently. Traditional package systems overwrite files in place. One interrupted update or a clever but dangerous install can leave a system inconsistent or unbootable. nixos approaches this problem by designing package management and system configuration so they don't overwrite. They add new, isolated artifacts instead. Explain how Nix works. At the heart of nixos is the Nix package manager. Instead of installing a package into a single global location, Nix builds every output in the Nix store under a path derived from the full build instructions and dependency graph. Because each output is stored immutably and uniquely, different versions can coexist without conflict. That makes upgrades atomic. Either the new configuration is complete and applied, or the system remains on the old one, and it makes rollbacks trivial. In short, reproducibility and transactional updates are built in. Real-world, developer and user benefits. That architecture unlocks real-world benefits. Developers can declare exact runtime environments with tools like nix-shell and Flakes, so that it works on my machine becomes a solvable problem. Everyone can run the same environment from a single definition. Teams can pin builds, share environments, and audit changes in a way that resembles version-controlled infrastructure. For power users, that means experimenting with bold changes is low risk because you can always boot a previous generation. Demo scenario, visual idea. Visual idea for the video. Show a user installing a risky app or changing a desktop config. Then run a nixos-rebuild to update and one click to roll back. Quick, dramatic, and satisfying. Narrate how nothing in nix/store was overwritten and the system boots exactly as before. Challenges. Honest take. nixos isn't magic. There are real trade-offs. The Nix language and ecosystem introduce a steep learning curve for newcomers. You'll edit declarative configs rather than clicking GUI package managers, and some error messages can be opaque. Disk usage can be higher if you keep many generations or large build artifacts, and the tooling has legacy cruft that can confuse users until they learn the patterns. In short, great power, but you need to invest time to unlock it. Comparison: nixos versus OSTree-based immutables. It helps to compare nixos to other immutable approaches like Fedora Silverblue or OSTree-based systems. OSTree-style images snapshot an entire file system tree and are excellent at delivering a single atomic image. Nix's approach is more fine-grained, layering purely functional package outputs and letting users declaratively compose both packages and system configuration. Both give you atomic updates and rollbacks, but they reach that goal from different design trade-offs. OSTree emphasizes immutable images. Nix emphasizes reproducible package graphs and highly composable configuration. Who is it for? So, who should try nixos? Developers building reproducible environments, teams needing audited and versioned infrastructure, hobbyists who enjoy deep control, and anyone who has been burned by fragile updates. If you want a laptop that you can experiment on fearlessly and restore to a known state in seconds, nixos is worth exploring. Future and adoption. Will nixos become the desktop Linux? That's uncertain. Its ideas are already influencing tools and workflows across the Linux ecosystem. Reproducibility, declarative config, and atomic updates are trending. Even if Nix never becomes mainstream on every desktop, its concepts will likely continue shaping how distributions think about stability and reproducibility. Wrap and call to action. If you're curious, start small. Try Nix on a VM. Experiment with a Flake-based dev shell for a single project, or spin up a live NixOS USB. If you want, I'll include links to official guides and a simple flake.nix demo in the description. Hit like if you want a follow-up video showing step-by-step setup and a real rollback demo. And subscribe for more deep dives into how Linux is changing under the hood.